The Grasberg Mineral District is located at an elevation of approximately 12,000 feet in a spectacular mountainous setting in the highlands of Papua, Indonesia. Freeport has operated for over 58 years at this site and has been engaged in underground mining of various ore bodies in the district dating back to the 1980s. The massive Grasberg ore body was mined from the surface as an open pit for a 30-year period beginning in 1990 and transitioned to a fully underground operation in 2019. The Grasberg Block Cave is a continuation of the Grasberg ore body at depth, situated 300 to 500 meters beneath the surface. Production from the Grasberg Block Cave commenced in 2019 following an approximate 15-year development period. During this period, Freeport developed massive underground infrastructure and modern systems using the most advanced technology available in the global mining industry. In the block cave mining process, the ore body is divided into large sections referred to as production blocks. At the Grasberg Block Cave, there are 5 production blocks within production blocks 1, 2, and 3. Within the mine, there are multiple levels, including the undercut, extraction, and haulage levels, which serve various functions. Additionally, a service level is located between the extraction level and haulage level. The service level provides ventilation and includes power and communications infrastructure. At the undercut level, the rock mass is cut, and caving is initially induced by blasting, after which the blasted rock is removed, creating a void. With gravity and internal rock stresses, the rock begins to fracture and cave under its own weight. The cave material is fed through funnel-shaped drawbells, designed to collect the collapsed rock to draw points. At the extraction level, located about 20 meters below the undercut level, remote loaders access the draw points to pick up the broken rock, which is then transported to a grizzly and rock breaker. This material is fed into a chute pass, which drops the ore about 50 meters to the haulage level, into a fully automated electric-powered train system. From there, the trains carry the ore to unloading stations that feed crushers. The crushed ore is then transported on inclined conveyor belts to the mill stockpiles for processing. Throughout its 4-decade history in underground mining in the Grasberg district, new technologies have been developed and adopted to continuously reduce risk and enhance safety performance. PTFI has been at the forefront of new technologies, working with suppliers and industry participants to develop systems and technologies to manage risks associated with underground operations. The mine is located in an area with heavy rainfall, approximating 5 meters per annum. PTFI has robust water management programs, including collection, drainage, and monitoring, and systems to divert rainwater from the former open pit. Water from the surface percolates through permeable rock and travels into the underground mine, where it is effectively managed through gravity drainage systems, allowing water to exit the mine at the AB tunnel drainage level. There are areas of the ore body that generate fine material at the draw point. As water moves down through the broken rock in the cave and encounters these finer areas, we are susceptible to wet muck spills, which are generally limited to the volume of the drawbell. Because of these conditions, PTFI has comprehensive safety controls and work practices to protect our people from the risk of localized wet muck flows. Freeport's design at the Grasberg Block Cave includes the use of automation at the extraction and haulage levels. This hazard is effectively managed in the mine through the use of autonomous loaders, comprehensive monitoring, the use of exclusion zones, including real-time area isolation management systems, and blending strategies. Other safety measures are taken to transport the wet muck from the mine to the mill via the ore flow system. These controls have been highly effective. On September 8, 2025, approximately 800,000 metric tons of saturated surface material entered the mine in an uncontrolled fashion. The source of the material came principally from the bottom of the open pit, above the Grasberg block cave ore body. The force of the external mud rush breached safety protections at the extraction level and traveled to multiple levels of the mine, resulting in 7 fatalities. The nature of the incident is unique in PTFI's long underground history and is different from wet muck incidents PTFI routinely manages. The material originated from the surface area at the bottom of the open pit, which accumulates water and settlement material from pit wall subsidence. PTFI's existing monitoring systems did not detect the pending, uncontrolled release of the material. The incident occurred in a panel in production block 1C, directly beneath the low spot of the open pit, which, over time, had collected saturated fines. The conditions in PB1C are different than those in PB2 and PB3. PB1C has relatively short draw columns, and the cave back shape in this area was inclined. These conditions caused several adjacent draw points to extract material from the same narrow zone, rather than from the area directly above each draw point. This led to a zone of faster flowing material connecting the bottom of the pit to the draw point, allowing wet fines to fluidize and rapidly enter the mine. During the incident, the mud moved rapidly through the extraction panels, entered the exhaust raises, spread across both the extraction and service levels, eventually traveling through the chute passes to the haulage level, and then moved through drain holes down to the drainage level. The volume of wet material entering the mine was estimated at 360,000 cubic meters, extending over 9 kilometers of mine tunnel, out of a total of 180 kilometers in the mine. The volume, energy, and mechanisms of this incident were unique in PTFI's history. A large volume of flowable mud traveling from the surface through an unknown and not previously recognized vertical pathway was both unprecedented and unforeseen. We mourn for our coworkers lost in this incident, and their memory will continue as we go forward to restore our operations safer and stronger. The entire Freeport team is committed to taking all steps necessary to avoid recurrence. The learnings from this tragic incident highlight the need to incorporate more dynamic cave management plans and operational procedures to address areas subject to risk from a mud rush. In addition, new innovative approaches to mud drainage solutions for the pit bottom, emerging imaging technologies to improve cave shape monitoring, and strategies for managing fines will be pursued to further manage this risk. The people of Freeport are our most important asset. Over the years, the Freeport team has overcome many challenges, starting with developing this world-class operation in a remote and complex physical location and expanding it to one of the largest copper and gold operations in the world. Team Freeport is committed to overcoming this challenge and to restoring its business in a safe and sustainable manner for the benefit of its many stakeholders.